Okay, so today's chapter 34, we're talking about computerized impressions and restorative systems. So this starts on page 798 of your dental assisting textbook, and some of the things that we'll be talking about is identifying and explain the computer-aided design and the computer-aided manufacturing restorative systems. We'll talk about the advantages and disadvantages of the CAD-CAM. We'll explain the role of the dental assistant during cavity preparation and while using the CAD-CAM system to design and manufacture an indirect restoration. We'll talk about the consideration the patient should be made aware of when using CAD-CAM technology. And we'll talk about how the CAD-CAM systems are used in the dental office and in the dental lab. Lastly, we'll describe the steps for preparing the tooth, designing the restoration, and manufacturing the final restoration. So this is one of my favorite chapters because it deals with CAD-CAM, and CAD-CAM is one of the things I happen to expertise in within the dental assisting role. It's something that is somewhat newer in the dental field, but it has gained lots of popularity over the past several years. So CAD-CAM stands for Computer Aided Design and Computer Aided Manufacturing. This is used both in the dental office and the dental laboratory, and it's capable of many procedures from digital impressions and design to the production of complete restorations. It can also make surgical guides, fixed partial and full dentures, implant abutments, and they are also starting to use it with orthodontic appliances. So there are some advantages of CAD-CAM. Number one, the procedure is complete in one day. Okay, normally, like how we learned in the previous chapter about cast restorations, is that the patient needs to be in a temporary restoration, and then they will have to come back 2 weeks later to cement the final restoration. Well, with CAD-CAM, all of that is done one day, so there's no need for them to return for that second appointment. Also, there's no need for impressions. Everything is done digitally. So there's no physical impression material that needs to be made. Lots of times patients gag on this stuff. It doesn't taste very good. And there is possibility for distortion during the transport from the office to the lab. Also, there's no need for any provisional or temporary restorations since the restoration will be completed in one day. There's no need to actually have to fabricate a temporary. There's also a reduction of tooth sensitivity because of the fact that the patient doesn't have to be in temporary restoration, which often don't fit completely well and have gaps and holes where the environment can enter through basically and cause sensitivity. It's time saving in that the patient doesn't have to reschedule another appointment to come back to finish the restoration. And there's no need for any dental lab involvement for many cases, which is excellent because we can completely cut them out. We can cut out any costs associated with them creating a crown for us. So that's really nice, and it's really cost saving for the office as well. There are some disadvantages with CAD-CAM in that the cost may be more, not only for the patients, because these types of crowns do cost a little more for them, but also for the dentists, in that the initial investment of getting this equipment in the office can be upwards in the hundreds of thousands. So it also involves extra time for the dentist and dental assistant because of the fact that not only do they have to prepare the tooth for the restoration, but they also have to scan the tooth. They have to design the restoration. They have to manufacture the restoration, and then cement it within one appointment. Which is why that appointment may be long. Sometimes it can be twice as long because all that has to be done within that time that they're in the chair. So the role of the dental assistant may vary. It can be one, many, or all of these things. Number one, we can set up the scanner. We ready the software, get it prepared with the patient's name, all information, what tooth number we're working on, and the shade of the tooth as well. We can prepare the milling machine by placing the appropriate shaded block or appropriate sized block inside the machine to be carved into a crown. We can assist the dentist with the preparation of the tooth itself. If you're comfortable and you gain more experience with CAD CAM, you may also be able to scan and create the digital impression. We can send the specs to the milling machine, which is usually placed down the hall. And then we can also assist with the placement of the restoration. Some of the things that you can do as you also gain more experience, and something that I do as a dental assistant, is you can actually not only scan, but you can design restorations, you can create them, and you can fit them in, adjusting occlusion and interproximal contacts on your own with just general supervision. Some patient considerations that you need to keep in mind, and you need to let your patient know. You need to educate them first about the procedure. Let them know basically how the whole process works from start to finish. Since CAD-CAM is relatively new, a lot of patients may not know about the differences between that and a regular cast restoration. Also, the time commitment that will be required for that appointment, because there is no need for that second appointment where the permanent crown will be seated. It's all done in that one appointment, which may mean that it may take longer than an hour, which is the average time for a crown appointment. Sometimes it can take up to 2 hours. So you'll want to make sure that they're aware of that, and make sure that they're aware that they'll be in the office a little bit longer than usual, but that they won't have to return. They won't have to take more time off of work in 2 weeks to come back for a second visit. Also, the finances should be discussed with the patient. Sometimes these CEREC crowns or CAD-CAM crowns can be relatively more expensive than a regular cast restoration. So CEREC stands for Chairside Economical Restorations of Aesthetic Ceramics. And CEREC was developed in Switzerland in 1980. Okay. CEREC is just one of the many different CAD-CAM systems. It happens to be one of the most popular ones, and one of the most easiest to use, and the most stable. It's the system that I'm more familiar with as well. There are several factors to consider, including the time investment to train the staff, the large financial investment that it takes to initially get all of this equipment into the office, and the computer familiarity necessary to operate the CEREC. So CEREC restorations are done as follows. First, the patient is seated and anesthetized. A ceramic shade is selected, and then the ceramic tooth is prepared. Well, rather, the tooth is prepared for a ceramic restoration. And that means drilling away pretty much all around the tooth, 2 millimeters all the way around. In the older systems, it was necessary to coat the prepared tooth with a reflective powder, which is what that type of camera read. Thankfully, we don't have to do that anymore. These newer systems have something called an OmniCam. That is the newest technology of camera available, where that reflective powder is no longer needed, and we can now scan and image teeth without having to use that extra step with the powder. So then the camera is prepared for the optical impression, where it will then scan the tooth, and then the restoration is designed from CEREC data. The CEREC restoration is then completed when the milling machine mills the restoration. The restoration is then tried in position, and sometimes fine adjustments need to be made. Once it is deemed that the CEREC restoration is fitting perfectly, the restoration is bonded into place. Okay, they are not cemented with the same type of cements that a cast restoration is cemented, because they are fully porcelain. They are bonded into place, and then they are polished. So taking virtual impressions, the intraoral camera is used to scan and record a digital impression. It then renders or creates a 3D rendering of the tooth or the area or that quadrant of the mouth that we're working in. And lots of times retraction cord may be used and sometimes necessary to visualize more anatomy, or more importantly, the complete margin of the tooth. When fabricating and milling the restoration, reverse engineering allows the creation of the virtual restoration. And once it's designed, the milling machine can read the restoration and then manufacture it. With this, only ceramic materials are used. When completing the restoration, the final restoration is tried in the patient's mouth. Sometimes adjustments are made as needed, and the restoration is cemented or bonded and then polished. We can, or rather CAD/CAM is used in dental labs. So when CEREC first rolled out, probably 10, 15 years ago, when it started getting more traction and gaining more popularity, a lot of these laboratories knew that in a lot of situations they may be phased out completely. So instead of going against the CEREC technology, they embraced it. They actually will provide a service where they will design and mill the restorations and then send them to you so that you don't have to. This may be beneficial in lots of offices where they tend to be high flow crown producers, and maybe they don't have the time to design and fabricate these restorations themselves. So that they might actually they'll send the whole file over to the dental lab and they will do it for us. So the benefit of this is it still reduces equipment costs for the dentist. So we are still having the labs create this restoration for us. So we are still paying them to do it. But another way that cost is reduced is that we don't have to take physical impressions of the patient's teeth. Okay, a lot of times the physical impressions that we use for normal cast restorations are very expensive, especially when you're working in a high flow office where lots of these impressions are taken. This cost and impression material itself can add up quite a bit. So by using a digital scan or a digital impression, we aren't having to use any physical impression materials, thus reducing the equipment cost. Also, often the office systems and the lab systems interface and communicate instantaneously. They communicate instantaneously, excuse me. What this means is that, say, for example, you have to send out a case to the laboratory. Normally, in a normal physical impression, you would have to sterilize, or excuse me, and disinfect the impression. You would have to wrap it up. You would have to package it up, create a lab slip, and then either have UPS or FedEx come and get it, or sometimes you would actually have to drop it off at the post office. So the nice thing about the lab systems and the office systems communicating instantaneously is these files can be transferred to the office that you want, literally with the click of a button. So it saves the assistant a lot of time and hassle by not having to do all of those things with the physical impression that I just talked about. So that's everything that I have for chapter 34. Please let me know if you have any questions. And thanks for listening.